Alright, in this video I'm going to walk through an example using the geometric probability distribution. Okay, so first let's go ahead and read through the example and talk about why it is the geometric probability distribution. So suppose we know that 80% of homes in a small town in Idaho have a dog. Okay, so this is very important, and we're talking about whether or not you have a dog. So we have two options there. Either the homes have dogs or they don't, and the probability that they do have dogs is 80%. Okay, so let n equal 1, 2, 3, etc. represent the number of homes you need to randomly visit before, you find a home with a dog. So basically we're going to go around visiting homes and say, do you have a dog? Yes or no? Okay, so we're asking a yes-no binary type problem, right? Two choices, and we know the probability of success is 80%. Okay, so these are all important things when you're thinking, okay, all right, so is this a geometric distribution? Well, I need to be asking a yes-no question, right? And then I need to stop as soon as I get my first yes. Okay, so as soon as a home has a dog, I stop. And what's random is the number of homes I have to visit. Okay, so the number of trials is random. All right, so it's similar to a binomial distribution where you have two choices, right? But what's different about the geometric distribution is that we don't have a fixed number of trials. Rather, the number of trials depends on how long it takes us to find our first success. As soon as we get our first success, we're done, right? That is a geometric distribution. Okay, but if you didn't recognize a geometric distribution right away, that's okay. Let's go ahead and let's think this through. So first, starting with P. P is going to be our probability of success. In this case, our probability of success is 0.8, right? So this is the probability a home has a dog. Home has a dog. Okay. All right, and then I'm also going to do Q, and Q will be the probability of a failure, right? So if the probability of success is 0.8, then the probability of a failure is 0.2. Now remember, whenever you're talking about probability, you need to convert from percentage to decimal, right? So basically 80% of homes have a dog, and 20% of homes do not have a dog, right? So this is the probability a home does not have a dog. Okay, so this is basically the probability of failing. All right. Okay, so let's think through this first question. What's the probability that n equals 1? The probability n equals 1. What does that even mean? What does that mean? That means that in your first home, you had success. Your first home had a dog. Okay, so that means you had one success. So that's basically that first home was a dog. You had a dog. You have an 80% chance of that happening. Okay, because the probability that any of the homes have a dog is 80%, so 0.8. What about the probability that n equals 3? All right, if n equals 3, then what happened? You went to your first home and they didn't have a dog. So the first home did not have a dog. So basically, this is going to be the probability of the first no dog, right? And the second no dog, right? The first and the second had no dog. And the third had a dog. Yay! Has dog. Okay? So the third was a success. Now, another point, in order for these to be a geometric probability distribution, you need each of these homes to be independent of each other. And since it says we are randomly visiting different homes, we have that independence assumption. So it's not like first person knows the second person and they know the third person. These homes are just very independent of each other, right? There's no relationship between these homes. So because of independence, right, we can use the multiplication rule. This is basically the same thing as the first no dog, right, times the probability that the second has no dog times the probability that the third has no dog, right? Or has a dog, sorry. The third has a dog. The third has a dog, right? So basically what I've done is I've just used my multiplication rule, and I said, oh, if I have and, then I have independence, and I know I can break this down using the multiplication rule into these three probabilities. Okay, so what's the probability of not having a dog at the first home? Right? That would be 0.2. The probability of failing, 0.20, right? Not having a dog at the second home is also 0.20. All right? Having a dog at the third home is 0.80. Okay? And then from here, I can open up Excel or my calculator, and I can figure out what this equals. Let me get my Excel to work. So I can type in equals 0.2 times 0.2 times 0.8. And press enter, and I get 0.032. Okay. 0.032. Let me just double check. Yep. Okay. So the probability that my first two homes do not have a dog and then the third one does, which is basically the same thing as n equals 3, is 0.032. Okay. One thing I want to point out before I move on from here is basically what happened here. I had how many failures? I had 2 failures, right? And then 1 success. So basically, this is the same thing. I could have written this as 0.20 squared times 0.80, right? That's exactly the same thing, right? 0.2 times 0.2 is 0.2 squared, right? And then times 0.80. Okay? All right. So what about writing the formula out in general? How do we write it out in general? So basically, what is the probability of n, right? Where I just leave it as n, and I'm not going to plug in a specific number for n. What's the general probability distribution function look like? Okay, in general, I'm going to have failures first. And how many failures do I have? Right? When n was 3, I had 2 failures. Right? In general, I'm going to have n minus 1 failures because I'm going to save that last one for the success. So the success gets tacked onto the back. Oops, let me erase that and make that a little clearer. Okay. So I have n minus 1 failures and then the success out in the back. And this is a multiplication symbol. Okay. Now, if you're plugging this into, WebAssign or, trying to type this out using a computer, the way you write this n minus 1 in the exponent like that is you write 0.20 and you use parentheses around it, and then you write this little caret, okay, which I think is you write shift and then the number 6 on your keyboard to get the caret. And then you write n minus 1. And then you write the multiplication symbol, which is shift and then the number 8 on your keyboard. And then you write a parenthesis and you write 0.80, right? So on a keyboard, this is the way, this little caret symbol, which again, shift number 6, that's how you get that little caret, and that means exponent. And this is the way you would write this out on a computer. Okay. So in general, the probability distribution function for a binomial is this. Right, so you can look this up in your, in your textbook, or if you just Google the geometric probability distribution function. What it looks like is q, right, or 1 minus p, same thing. Q to the power n minus 1 times p. Right, so this is 1 minus p to the n minus 1 times p, right? Because 1 minus p is the same thing as q. Okay. All right. And of course, we've just plugged in for our particular case what P and Q are, 0.2 and 0.8. Okay, what is the expected number of homes that you must visit before you find a home with a dog? Okay, so expected, whenever you see the keyword expected, that's basically the same thing, so it is as like the mean, right? So if you know the mean, mu, for a geometric probability distribution function, it is 1 over p. Okay, so expected and mean are basically the same thing. All right, so this equals 1 over p in our case is 0.80. All right, the probability of success. So you can pull out your calculator and you can type in equals 1 divided by 0.80 and then type it enter sign and you get 1.25. All right. 1.25. So on average, you have to visit 1.25 homes before you find a home with a dog. All right, and read the instructions carefully. Sometimes you have to round expected numbers like that to the nearest whole number, in which case this would just be 1, right? But it's okay to leave it as a decimal as well. Just make sure you read the instructions of whatever question you're trying to answer. On average, we are visiting 1.25 homes, so meaning sometimes we'll visit one home and we'll find a dog, and then other times it may take us 2 times to visit a home before you find a dog. Okay. All right. Thank you for watching. If you have any follow-up questions, please don't hesitate to go ahead and post there in the comments. Thanks.